In this lesson, we'll talk about ways that you can describe functions. To be a function, each input has to have exactly one output, and there are at least 4 ways you can describe functions or show functions. You can write them as ordered pairs, you can use a mapping diagram, which is what we have shown here, you can use a table, or you could use a graph. And so here in this mapping diagram, you can see that we have 3 inputs, and each of those inputs has exactly one output. So 3 inputs, we have 3 arrows going to the outputs. Remember, if we have a graph, we can use the vertical line test to determine if that graph shows a function. If it passes the vertical line test, it's a function. If it fails the vertical line test, it would not be a function. Now, if it is a function, it can either be linear or nonlinear, which means if it's linear, the graph is a line. As you can see in the word linear, the first 4 letters spell the word line. And so if it's a line, that equation can be written in slope-intercept form, which of course is y equals mx plus b, where m is the slope and b is the y-intercept. And so if you're looking at the equation, the variables in the equation, or the variable in the equation, would have a power of 1. And so an example of a linear function would be y equals 2x plus 3. If you were to graph this equation, it would be a line, and 2 would be the slope, 3 would be the y-intercept. Now, functions can either be linear or nonlinear. So if it's not a line, it's not a line, which we call non-linear. So the graph is not a line, therefore the equation cannot be written in slope-intercept form. And so an example of a nonlinear function would be y equals x squared. If you were to graph this equation, the graph would look something like this, like a U shape. And so, of course, as you can see, it's not linear. Now, if the function is linear, it can either be what we call proportional or non-proportional. So proportional means that that line passes through the origin. It passes through 0, 0. And so an example of this would be y equals 3x. This is still in slope-intercept form. You may be saying, where's the b? I don't see plus anything. Well, if it goes through the origin, the y-intercept would be 0, and so the equation in slope-intercept form would be y equals 3x plus 0. But if we're adding 0, we don't need to write that, and so you're just going to see the equation like this, y equals 3x. But since this line passes through the origin, that makes it proportional. Now, if it does not pass through the origin, we call that non-proportional. It's non-proportional because it does not pass through the origin. It does not go through the point 0, 0. And so an example of this would be y equals 2x plus 3. As you can tell, the 3 there, that's the y-intercept. So it passes the it passes through the y-axis not at 0, but at 3. So it's non-proportional.